everyone, and thank you for attending this Digital Twin Consortium webinar, Digital Thread Powering Digital Twins, presented by DTC Steering Committee member Northrop Grumman. It is my great pleasure to introduce our speaker today. Brian Schmidt is Chief Engineer and Tech Fellow in Digital Transformation at Northrop Grumman. Thank you for joining us, Brian.
Thank you very much, Meg. So, good morning to all of you. Maybe good afternoon, depending on where you're dialing in from. I'm very excited to have this opportunity to share with you some information about my company and my perspective and our mutual perspective on digital twin capabilities. Look forward to sharing with you a little bit about my company's journey with digital transformation and digital twins, and why we feel so strongly about this topic. So let's get started. This is Digital Thread Powering Digital Twins Throughout the Life Cycle at Northrop Grumman. I'll share a little bit more about myself. So again, my name is Brian Schmidt. I'm a Chief Engineer and Technical Fellow in the Northrop Grumman Mission Systems Sector Digital Engineering Center. In that Digital Engineering Center, I'm very active and involved in our digital transformation activities throughout the sector. In addition, I'm very fortunate to also be connected and be involved with our corporate enterprise level digital transformation office activities. Again, also digital transformation activities that stretch across our enterprise. And through all of this, specific focus on digital twin capabilities, enabling the efficient and effective use of digital twins. In my career, I have over 20 years of engineering experience in the defense industry with Northrop Grumman, and I've been working in models since I started my career. I've spent a significant amount of time working with our customers to model and simulate enemy threat weapon systems leveraged on combat training ranges to prepare our warfighters to come home safely by defeating those threats. And that was something that was instilled in me by one of our customers, that focus that it's really about bringing our warfighters home so that they can spend time with their family, absolutely achieving mission success. But again, it's about bringing them home safely. So let's talk a little bit about Northrop Grumman. So we're a leading global aerospace and defense technology company. So what gets me excited to go to work each day, what I love about working at Northrop Grumman, is our products connect and protect our warfighters, allow them to achieve their mission of protecting our country and the world, and push the boundaries of exploration even beyond our planet. I find this extremely rewarding. Again, something I'm very passionate about. So our employees are defining possible every day. So what is it that we do? So we design, develop, build, and support some of the world's most advanced products and platforms. From advanced aircraft platforms like the B-21 Raider that you might have heard about in the news over the last year, to next generation spacecraft, to unrivaled cybersecurity systems, all-seeing radars, even some out-of-this-world telescopes such as the James Webb Space Telescope. So if your experience has been anything like mine, especially again over the last year, your social media has probably been flooded by amazing, astounding images of our universe, things that I don't believe I thought I would ever see in my lifetime. This is exciting. This is a fraction of what we do at Northrop Grumman. This is that forward-facing, side. We're going to talk a little bit today about what you're not seeing, again, that digital transformation, the digital twins. Northrop Grumman is made up of 4 operating sectors. Our business sectors offer an extraordinary portfolio of capabilities, technologies, and workforce talent that combine to help our customers around the world meet their most complex challenges across all domains: air, cyber, land, sea, and space. Specifically, as I mentioned, I reside in the mission systems sector. There, We provide advanced solutions, multi-function systems, primarily to defense and intelligence customers, along with international customers. All right, so let's dive into this journey a bit. So where did Northrop Grumman's digital transformation journey begin? It began with our customers. So the defense industry continues to undergo a digital transformation, where digital tools and processes enable faster, more affordable solutions that are secure against modern threats and adaptable to meet future needs. I'm highly confident I'm not the only person sitting here that has gone through the digital transformation journey, and the Northrop Grumman is not the only company that's gone through this journey. Many of you have been there or are there. For us, digital transformation is all about our customers and their mission. We look at it in terms of mission requirement. The use of digital technologies means we can address the mission with insights like never before. The shift is something that Northrop embraced as a shift towards a digital engineering ecosystem, which would ultimately support the product lifecycle by bringing together our employees, our customers, and partners in an integrated digital environment, collaborative environment, where we could all work together to evolve our designs. It's a move from stovepiped infrastructure and static data, disconnected documents, disconnected artifacts, to a much more model-based approach and incorporating the technology to link those models. I'm going to come back to that in a coming slide. Through digital transformation, we are leveraging the power of data to virtually design, build, and test our products. Again, together with our customers and partners, we're able to virtually interface in a common but configurable design data environment, driving speed, agility, and savings into the program. Many of us on this call, again, I'm confident I'm not the only one, can remember maybe prior to doing some digital transformation, the design process. And some of it's very much the same, so I don't mean to say that it's all changed. But as a systems engineer, taking those customer requirements, deriving them down, then ultimately handing them off to the software team, to a hardware team, to our functional teams, who then take those, go off, develop additional artifacts, do further work, further their design, and it continues on and on and on. Now, it might not be quite like throwing it over the wall, but in a way it was. Today, with digital transformation, a big part of that is that is now all seamless. So when the chief engineer, systems engineer derives their requirements down, right? They're still deriving the requirements down, absolutely, handing them off to the teams. But in that way, it's all done digitally. They stay connected the entire way. Those artifacts remain connected. And where they offshoot, we can follow them. It makes it a much more seamless integration again. This digital transformation is a cultural transformation. Again, I'm sure many understand this, but I would say that is probably the most difficult part. And it continues today for us, for Northrop Grumman, for our customer, because our enemies are evolving rapidly. We need to stay ahead of them, not keep pace, but stay ahead of them to support our customer. So let's take an example of one sector's journey. So as I sit here talking with you today from my hotel room, hope you enjoy the view here. Digital engineering is not a new concept to Northrop Grumman. We've been leveraging it for many years. So if you look at this slide, notice that timeline where it starts, early 2000s. It started with tool upgrades on major programs, continued on model-based design, product lifecycle management, partner-customer integration and engagement. You could probably assume that each of these major points on this timeline relate to a major program activity along the way that help drive it. Now, this journey continues today and into the future with an enterprise-wide digital transformation spanning all of the sectors that I introduced earlier. This is one sector's journey that's outlined here. Ultimately, this same model is applied across our entire enterprise. How did we link those models as discussed on the previous slide? Right, so I said I'd come back to that. Ultimately, this is the forming of the bidirectional digital thread. That is the image that you can see cutting through the middle of this slide. Hopefully you find it simple to view. It starts with the customers. You can see that, just above that NG logo. So it starts with the customers and our suppliers, interacting with them, moving into the shaping, up into proposal and capture, moving through system design, again, global supply chain, bringing our partners in so that we can work through this design collaboratively. Moves on into integration and test, build and test. Now we're actually building, we're producing, and it does not end there. So we deploy our systems, these platforms, to the field. And again, the story continues, the journey continues. We follow those systems into operation and sustainment, leveraging the physical and the virtual, the digital twin, side by side, and bringing that data back through that bidirectional digital thread. So I'll share with you. So yesterday, Dan Isaacs, again, Digital Twin Consortium, made a comment along the lines of, you're not fully digitally transformed if you're not employing and leveraging digital twins. I would tend to agree with him. It was a perfect point that I wanted to share with this slide. Let's get that slide to advance. There we go. Let's dive deeper into this digital thread. The connected bidirectional digital thread supporting our digital twins is a key piece to this full life cycle story. As we look at this diagram, I'm going to walk you through how we use digital twins and the terminology we use. So I think that's important. There are many definitions out there and many opinions and thoughts about digital twins. I'm not trying to say one is right and the others are wrong. What I do feel is important, though, is sharing and level setting by providing the terminology that I am using, that we are using, so that when we have a discussion, when we talk, when we share information, that we can understand, you can understand where I'm coming from. So at Northrop Grumman, we align with the Digital Twin Consortium's definition. So digital twin is a virtual representation of real-world entities and processes synchronized at a specified frequency and fidelity. Of course, in aerospace and defense land, our specified frequency might be a little wider than some others. Sometimes joke, right? It's a little different than our washers and dryers that may be connected right to the internet. We might need to do some extra work to get the data back from our systems. So let's, again, dive in here. So this all begins back with mission engineering and mission simulation and analysis. Very beginning, down around point 1 there, bubble 1. So what are we doing there? We are working with our customer to model the mission long before we're on contract to build. We're working to understand the problem space, working with our customer, ensuring that we understand the solution, so that then we can continue on leveraging digital twins at that point. Even move through that requirements, again, mission engineering, functional system modeling, analysis of alternatives, continues on through design. During that time, we're building and evolving the prototype digital twin prototype, the as designed digital twin, leveraging the best design information that we have at a given time. The data we're using may be synthetic or maybe it's off of something similar that we're able to leverage. We're using that to evolve and optimize our design, make it the best that it can be. The story continues on through simulation, test and verification, into manufacturing, intelligent manufacturing, production, automation. At that point, we're talking about the as-built digital twin. So now we may have a physical thing in our facility, in our factory, that we can, again, begin learning from. We can pull metrics from. We can inform our model, inform our digital twin, which has now progressed then from digital twin prototype to being a digital twin synchronized with the real. Once again, the story does not end there. It continues on. So we continue moving through, we deploy, we put that system into operation, sustainment. And once again, we're talking about now what I would refer to as the digital twin aggregate, digital twin instance. Digital twin aggregate maybe being related to a lot production run specific to that time frame of those systems as they were built. Digital twin instance may be specific to a tail number, a serial number. Once those products, those platforms are employed in the field, they are out in the field, they're being maintained and sustained, things change. Our military makes the updates they need to do, makes repairs, maybe due to the environment, there's some changes in how it operates. We bring that back specific to that digital twin instance. Leveraging this engineering rigor across the full thread is what makes it valuable. This is a bidirectional thread to support informing the digital twin with data from the physical, and again, thus maturing that digital twin, empowering it to solve the challenges of tomorrow. The forming of this bidirectional thread enables data-driven insights like never before, reducing risk through enhanced visibility, bolstering the quality of our products, and improving manufacturing operations. This has enabled our program performance so we can continue to deliver with speed, quality, and efficiency. So let's dive a little bit deeper into this digital thread, digital twin, really digital engineering. It's all about optimizing our product design, getting more and more confident before I order my first bolt, let alone turn the bolt, order the bolt. Before we even bend metal, we've already modeled it. This leads to increased customer confidence and decreased risk. We're ultimately decreasing uncertainty by leveraging data from that digital thread and employing it to power our digital twins. Connecting the digital thread from the capture phase through requirements, model-based design through model-based manufacturing, test and integration, and all the way to model-based simulation is critical to the employment of digital twins, as the maturity of the twin should increase as that product lifecycle progresses. As the world changes, sadly, we're hearing about scary events in other parts of the world, all over the world. At any time, our customer could call on us to understand how to leverage their platforms, their products effectively. Could talk through a hypothetical scenario. There's a new threat. Customer doesn't know quite yet how it will respond. We can rely on our digital twins, our digital twin instances, to confidently answer the call and drive mission success. So let's think about that. We go back to our mission engineering, mission simulation and analysis. So all the way back to the beginning now, a new problem set. Work on modeling, simulating that arena, that problem space. Help our customer to understand maybe how they could employ these and how effective something might be, so that we can confidently answer their call so that they can make the decisions they need to make, maybe employ a specific serial number, tail number, given where it happens to be in the world, and know how effective it will be. So we can rely on our digital twins, digital twin instances to confidently answer that call and drive mission success. And again, bring it back, helping keep our warfighters safe and protecting interests throughout the world. This is what we do. This is how we're employing these technologies and why I'm so passionate about them. Well, before time runs out here, let's talk about building these digital twins. So at Northrop Grumman, we like to say, leveraging model-based everything. We need to do this at all levels, leveraging those digital twin capabilities, building and evolving the digital twin as you move through the life cycle, enabling digital twin development through modeling and simulation, harnessing what we've done before and linking together through the digital thread. Again, I mentioned earlier, maybe leveraging some similar data when we're working with our prototype. So let's talk about the data for a little bit, right? So again, it's employing data, digital prototype, maybe it's synthetic data. And as we progress into the as-built, pulling in some telemetry data out into the as-maintained, pulling back some maintenance data so that we can inform our models. And what models? Could be any subset of the models shown here. Threat models, environmental models, mission simulation, CAD models, even cost models, understanding how those costs apply, again, bringing supply chain in. In the meantime, as we talk about this, it's important to think about keeping modeling, digital twin creation, use case driven. We shouldn't model for the sake of modeling. Yesterday, Dr. Michael Greaves was hitting on this point, so it was exciting to hear him say it too, and I know that's a big one with DTC. Again, focusing on those use cases. All too often, I may mention about a digital twin. Hey, we're doing a digital twin, and someone will say, "Oh, does that mean I can look at it with VR glasses?" Well, maybe, if the use case is there for that. That absolutely is a use case too, a very powerful one. But again, we work with our customers to ensure that we're implementing digital technologies where it makes sense, where it provides the greatest value to our customer. That is a big part of the work that we're doing. And it's a challenging part. So in summary, we are working to ensure we meet our customers' needs, validate assumptions early, discover performance issues, alleviate risks efficiently, and identify future business opportunities by leveraging digital twins across that product lifecycle, building up model validation levels and qualifying our models. That is a very important piece too. We are using these models to make strategic decisions, maybe on what captures to go after. And again, ultimately getting down to, bring our warfighters home safe. So it is important that we understand our confidence level and can project that for our customer so we can quantify the answers that are coming out of our digital twin usage. We're seeing benefits at all levels of the business. Again, as I mentioned, leveraging twins in strategic decision-making and all the way through that product life cycle. It's used on major franchise programs along with smaller ones with success. Again, the value of the digital threads is found as we progress through that product life cycle. The key is leveraging that digital thread.